Please go to the page 186. Page 186. The topic is graphing functions. You have a part of the theory who uses this, and scientists can use a function to make conclusions about rising sea level. For example, sea level is rising at an approximate rate of 2.5 millimeters per year. If this rate continue, the function y equal 2.5x, you can describe how many millimeters the y representing the sea level will rise in the next x years. One way to understand the functions such as one above is to graph them. You can graph a function by finding ordered pairs that satisfy the function. Okay, graphing solutions given a domain. You can graph each function for the given domain. We have the example A, negative x plus 2y equals 6. The domain is from negative 4 until positive 2. Negative 4, negative 2, 0, and 2. The step 1 is solve for y, since you are given values of the domain or x. You start with the function negative x plus 2y equals 6. You solve for the variable. Okay, in this case, we need to solve for the variable y, simplifying, and okay, we are going to solve it on the board, don't worry. I'm only reading the exercise and watching what we are going to do. The step 2 is to substitute the given values of the domain for x and find the values of y. We have the values, we have the function, we have the values for the x, and we obtain the values for y. Okay, we are going to use the values of x, the values of the domain, to obtain some values for the y. When we have the ordered pair with the values of the x and the values of the y, we can graph the function. But we need to graph the function using both parts, the values of the x. Tell me, Gabriel.
I was in the class when you was passing attendance, but in that moment I was having trouble with the Wi-Fi.
Yes,
So that's why I don't answer.
Okay, I'm going to change this. The first step is to solve in my equation for the variable of the x. You have the equation, but remember, what shape does a function have? You have to start with the variable y, or f of x. So in this case, we need to isolate the variable y. We have this negative x. We have negative x plus 2y equal 6. We need to find the value for the variable y, because remember the form that it has 2 times y equal, you pass the x to the other side, it's negative, so you pass it positive, x plus 6. Now, what are you going to do? You can see that this number 2 is multiplying my variable, so I need to pass it to the other side to divide. So I have y equal 1/2 of the x, or x divided by 2 is the same, plus 6 divided by 2, that is going to be 3. And what is the domain you have? The domain you have for this function in the values of the x, it's -4, -2, 0, and +2. using these values, values for the x, we are going to replace each one of these in the value of the x and find one value of the y. Remember what we were doing yesterday in the example 4 and 5. It was replacing the values they give you in the function to find the value of the variable. Okay, so we are going to copy this function as at the top. I'm going to copy this function at the top, and later we are going to try with each value of the domain. The function is y equal 1/2 x plus 3. And the values we are going to use, -4, -2, 0, and 2. So if we try with the first value is going to be -4. So you replace, we can write it in the other, remember about this. You have f of x equal this function. It's the same that if I have the letter y. I'm writing this because I need you to remember about the function, okay? And when we write one value of this for the x, is that I'm replacing f of -4. So in each value of the x, I'm going to write -4. I'm going to erase it. I was only reminding you. So for the number 1, I'm going to write it like this. Y equal 1/2 x. X is -4. 1/2 multiplied by -4 plus 3. So you have that y is equal 1/2 of 4 is negative. I have -4 divided by 2. I have -2 plus 3. So in this case, y is equal 1, right? The other value we are going to have is -2. Second value, I'm going to replace y is equal 1/2 of -2 plus 3. Y is -2 divided by 2 is going to be -1 plus 3. So I have that y is equal to. For the other one, 3. Now x is going to be 0. Y is equal 1/2 of x. X is 0 plus 3. So y is going to be 3. Tell me.
The first part in what page it was?
My God, 186.
Okay, thank you.
And you ask until now. My God. Okay. In this case, y equal 3. And in the last part, you are going to write that x is equal 2. So y is equal 1/2 of 2 plus 3. Y is equal 2 divided by 2 is going to be 1 plus 3. That is 4. And what are we going to do with these values? This is the range of the function. It starts in 1 and it's going to be in finishing 4. So I'm going to write this in a chart. For the y, we start 1, 2, 3, 4. I'm going to erase this and I'm going to write it on the chart like in the example. This is the domain and we have the range now. This is the domain. Now we have the range. It's 1, 2, 3, and 4. We can write a chart. A chart in here. I'm sorry that this line is not completely straight. I'm going to try it again. Okay. I need the two values. The first one is the value for the x, and this is the value for the y. When x is -4, y is 1. That's why I need the chart to compare the values. And remember that I obtained the values of the y using the domain they give me. And the domain is related with the values of the x. When x is -2, y is +2. When x is 0, y is 3. And when x is 2, y is 4. When x is 2, y is 4. You can compare with the values you have on the chart that we have the same results. Now I only need to write this. I only need to graph this equation. When you are going to graph, you have this. You have in here, this is for x, and the vertical line is y. The vertical axis is y, and the horizontal one is x. We need to write. I'm going to write 1, 2, 3, 4. The same in here. 1, 2, 3, 4. But we have the negative numbers for the x too. So we are going to use the negative values for the x. Now I'm going to graph this. And you know that when x is -4, -1, -2, -3, -4, when x is -4, y is going to be 1. 0 and 1. So my point is going to be located in here because x is -4 and y is 1. Okay. The next one, when x is -2, y is +2. X is -1, -2 in here, and y is with the positive, so 1, 2. My point is going to be located in here. -2 for the x and +2 for the y. The next one, when x is 0, y is 3. When is going to be x 0? In here. In the center of the graph is going to be 0 for the x and it's going to be 0 for the y. So if x is 0, y is 3. 0, and you will count the value for the y. 1, 2, 3. So you are going to locate the point in here. 0 for the x, but 3 for the y. Okay, now when you have that x is +2, x is +2, and y is 4. 0, +1, +2 in here, and the y with the value of 4 is in up here. So this is the point you have. This is the graph you have. You start in -4. This is the domain of the function. You start in -4 for the x, and you finish in +4. Look at the domain of the function. You start in -4 and finish in +2. And for the range of the value of the function, you start in 1. You start in 1 for the y, and you finish in +4. Okay. Now, what other things we need in this example? Guys, I don't know if you understand this very well. Example?
Mr.
Yes.
How did you graft a ¿cómo se llama?
How I graph the points? Or what are you asking?
No, Mr. ¿Cómo se llamaban esos que va uno arriba y otro abajo? Yo no me acuerdo.
Fracciones.
I don't understand the question.
Fracciones. O algo así.
Oh, to graph the fraction. Or to solve it. Gabriel is
Yes,
not-
the fractions.
Okay. To graph it, you graph like a decimal. For example, if we need to graph 1/2, you're going to graph 0.5. You graph it like decimal. But in this case, we don't need it because when you multiply when we multiply by the value of the x, it converts in a whole number, like in the part of the y you have. But if you someday you need to graph a fraction, you graph it like a decimal number, okay? Okay, we can go to the example B. Maybe we can finish the example B. Graph each function for the given domain. The same we have on the chart, we find the value for y, only that in this case they don't write the y, they write f of x. Okay, this is easier, I think, this topic, but the complicated part is that we lost so much times when we graph this and when we are finding the values. So we only have one exercise finished and we only have 5 minutes for the class. Okay, the domain, the range, and the... Okay, I'm going to show you with the values you have in here. I'm going to change the equation. I need to change the points we are going to graph. I'm going to change this for the example 2. Maybe we can finish. If not, we finish tomorrow. The values for the x and for the y, the domain and the range. I'm going just to copy the information you have on the chart. In this case, we don't have y, we have f of x. It's going to be the same at the end, but it's a way that you see this ordinate in order. The domain is -2, -1, -2, -1, 0, 1, and 2. -2, -1, 0, 1, and 2. And the values for the y, I'm going to just copy the values. 2, 1, 0, 1, 2. I'm just copying the values they have on the chart, okay? So for -2, when the domain is -2, the range is +2. When this is -1, you have +1. In 0 is the same. You have +1 for the x and the y is +1. And for the last part, 2 and 2. And remember, we find these values replacing. We have the function f of x equal the absolute value of x. So we only replace the values in here. I'm not going to solve all the procedure because we don't have much time, but I'm going to explain you only this. For example, if you have that f of x is equal the absolute value of x, you replace f of, you're not going to write f again, you're not going to write x, you replace -2. F of -2 is equal the absolute value of -2. And what is the absolute value of -2? +2, right? That is the way you obtain the numbers, but I'm not going to write everything. I'm not going to write everything because in this function you only have the absolute value. Okay, the important part is that I want to show you how to graph in this case. Okay, it's the same like in the other functions, but the shape, the form of the function is going to be different. For each graph we have is going to be different. We start in x with -2 and y is +2. -2 in x and this is +2. So you place the point -2 and +2. -1 for the x and +1 for y. -1 for x and +1 for y. 0 equals 0. So what is the point 0 equals 0? The center of the graph. The other part, 1 equals 1. 1 for the x and 1 for the y. And the last part you have 2 for the x and 2 for the y. So I place my point in here. And this is the form. When you have a graph of an absolute value, the shape is going to have is like this, like a V. This is the graph of a absolute value, like a V. The only difference that I don't include all the values. In this, I include all the values when we have the continuous graph. But this is a discrete graph. This is a discrete function. So we only place the points. Remember the difference between the continuous graph and the discrete graph, like in here. In here, we don't include all the values. We are including only the values that are in my domain and in my range, okay? Some values for the x and for the y. Okay. So guys, I'm going to finish in here, I think. Tomorrow we can continue with the theory and with the other examples. I hope that you understand this exercise very well. If not, you can ask your questions tomorrow. Or unless you have to, you want to ask something. Okay. So Gabriel, do you have any question? Gabriel Ramirez? No. Okay. So see you tomorrow, guys.